Hey everybody, my name's Aaron. Welcome back to the channel. On today's video, I'm going to show you how to take this gutted 1976 Sony Trinitron TV and rebuild it with new technology.
Gentlemen, we can rebuild him. We have the technology.
So welcome everyone to the Retro Hack Shack. Now you may remember a little bit ago I tried to repair this Sony Trinitron TV from 1976, and after weeks of effort and hundreds of dollars of parts I wasn't able to restore it, and the likely culprit was a bad flyback transformer, which aren't interchangeable between different TV models. So what I wanted to do, I saved the shell of the TV. I took out the tube and some of the boards that are inside, took those out and took those to e-waste because I couldn't use those anymore. However, I just love the look and feel of this Sony Trinitron TV. It's just like a set that I had growing up. And so what I thought might be interesting to try is to see if we could restore it, bring it back from the dead, if you will, by using something like a flat screen LCD and maybe a few other tips and tricks and hacks to get some of the knobs and dials working so that you could relive the experience of this TV set, but you would be doing it with modern technology. So keep the look and feel, but modernize everything inside. That's what I want to do today. Now, as you know, the name of the channel is the Retro Hack Shack. And the hack, when I built the channel, I put it in there on purpose because some of the things that I like to do are hacking on old technology and adding something to it that brings it into the modern day or transforms it in some way. And I've done this several times on the channel. So if way back in the early days, I took a black modem and turned it into something that looked and sounded like Knight Rider. Then I took a doorbell and actually recreated the doorbell from Ferris Bueller's Day Off, including the sounds. When you push the button, Ferris actually comes on and speaks to you the same way he did in that recorded track.
Thank you for stopping by. I appreciate your concern for my well-being.
And of course, who can forget the RGB to HDMI device that I sell on my website, which actually takes the video output from many old computers and converts it to HDMI, full quality, crystal clear HDMI video that you can plug into any HDMI device and relive those days without actually having to have either an RF connection to a TV or the original monitor, because those can be really hard to come by these days. So it's in that same vein that I tackle this project today. So before I start, I want to talk about the plan and what I have in mind, and then we'll see how far I get. So like I said, CRT tube is gone, but I kept all the other electronics here because I'm hoping I can find a way to reuse these, maybe the tuners, but definitely like the power on switch here, right, that turns it on, the volume knob, maybe the hue, or maybe some of these buttons to control some of the features and at least keep that illusion going of having this thing work, even though the insides are basically going to be completely gutted. What I did was I took some very detailed measurements of the inside of this bezel, and I bought a kit. You can buy these from China. They're fairly cheap, and they come with various components. So inside we have a remote, which will be really handy because, just like in the old days in the 70s, I was the youngest, so I was the one that had to get up and change the channels on the TV because we didn't have a remote on our TV back then. There we go. So this is the input board, and you can see all of the various inputs that we have. There's actually HDMI, VGA, there's component, and there's even a RF input that you can do as well. I think this is for like a security camera, but we'll test that out and see how it works. But I thought this was going to be great because now I can put any input I want essentially into this old 1970s TV and bring it to life in a way that you would never have been able to do back in the 70s. So this is actually the control module. So you can see here the various volume up, volume down, menu buttons and so forth that you would use on a regular LCD monitor basically to be able to change the brightness and the contrast and all that. Plus there's an infrared component here for the remote as well. Now I could just take these controls and pop them through the back of the TV or even through the front of the TV and get access to these buttons. But I think what I want to do, this is how I basically want to interface the buttons on the TV to the controls here, so that maybe I can make it so that when you turn one of those knobs, it controls the volume up and volume down, for example, on this board. So that's one of the things I'm going to be working on. There's also a high voltage board in here, and this high voltage board is pretty dangerous. They do give you a caution here to be careful, but yeah, you do need to be pretty careful with the high voltage board that drives the LCD screen. And last but not least, we have the LCD screen itself. Now again, I took really copious measurements here, and I know it's not going to be exact. So I'm going to have some extra room, some extra width on the sides, and I'm hoping to be able to play with the controls a bit and then bring the picture in to so that it actually comes into right about here, because the rest of this will be hidden behind the bezel. So here's what's left of the TV. Probably most of this will all go away, and I'm just going to try to keep these knobs and then interface them with something else to make things work. This panel is 1024 by 768 resolution, so this is a 4:3 resolution panel as well, which is of course important. But you just can't find something that matches exactly. It's a little loose, but not much, and it actually fits in really nice behind these standoffs here. So I could even tilt this up right now, even though it's not screwed in, and we could take our first look at what this looks like. And actually, I have to say, it doesn't look too bad. There's a glossy protective cover on this. There is, of course, the gap here in the bezel. I think I can maybe do something about that with a little 3D printed part or something. But honestly, it doesn't look bad just sitting in this display. So if you've never seen these displays, these individual displays like this, they're pretty easy to hook up. I've got my high voltage board here, and then that connects back to this controller board, which feeds the power into the high voltage board. And then for the signaling to go from whatever you're bringing in to the panel itself, there's usually a cable like this. The only real question is, where do you put this long connector here? And you really kind of have to hunt on the board to find it. In my case, it's right up here at the top. And that's just a press fit connection. So that's it. All the components are hooked up. There's a few extra sockets here. This one actually says speaker, and this one says DC in. So I'm assuming there are different ways you could hook up speakers, obviously, and there's an alternate way to power this up if you didn't want to use the barrel jack, which is nice. Okay, let's go ahead and try the remote. I'll hit the power button. Green light comes on. And HDMI. Does it give us a signal? Hey, and look at that. It's actually working. Ooh. Okay, here's the menu. Pretty fancy for this type of thing. And this is nice too. We can change the color temperature from cool to warm, which warm is probably going to be better for this vintage TV to match a little bit better. Yeah, really fully functional controls here. This is great. It even has a little equalizer. You can turn up the treble or bass if you want to through this thing. You can lock this with a password. And then there are some other simple setup stuff for the on-screen display and logos and things like that. But yeah, this is looking really, really nice. I think this is going to work out perfectly. Okay, now I want to figure out how to tackle the problem of interfacing the controls with the dials on the front of the TV. This is the signal processing board, I guess, for lack of a better term. And this is where this would take the TV signals in, and then you could use this. That's why it's connected to these things up here. You could use it to test, tune for different colors and hues and all that kind of stuff that came with this Sony Trinitron TV. And it has this really nice bar here, or metal piece, that attaches to the pots. As you can see right here, they just screw in like that, and then they're soldered into the board. So I want to reuse this metal part here to make it easier for me to mod this and perhaps, put some different parts in here, but basically use this as kind of like the stabilization, because obviously everything's laid out already in where it needs to go. So if I can reuse this metal piece, that'll save me a lot of time. So what I want to do now is just disconnect the rest of this board from this metal bracket here. And to do that, I'm going to have to desolder all of these pots. Okay, I think I've got all these off here. Should just be able to lift this up and pull it out just like that. And here's what's left. It's just this bracket with all these pots nicely attached, and hopefully I'll be able to change those out if I need to with something like a rotary encoder. So since I just mentioned rotary encoders, let's talk for a minute about how I plan to use these 20th century dials and knobs to control the 21st century LCD display. I want to find a way to register turning the knobs as a button push on the control panel. This way I can control all the functions of the LCD display from the front of the TV and just make the illusion of a working 70s TV that much more complete. One way to do this is to replace the old potentiometers with rotary encoders. Rotary encoders have been around forever. In fact, I first became aware of them back in the day when I would repair old school ball mice. They are essentially a wheel with holes punched all around the edges. Light sensors are set up in line with the holes. When the wheel spins, the sensors register when the light shines through the hole as a high signal, or a 1. When the light is blocked, it registers as a low signal, or a 0. With a sensor on either side of the wheel, you can determine if the wheel is being rotated in one direction or in the other, and you can count how many times the light has been seen. This made this technology perfect for early ball mice that were used with the early PCs. So based on this, I can use a rotary encoder and a microcontroller like this ESP32 to send a signal to the control panel every time I turn the rotary encoder either left or right. Perhaps turning it right can trigger the volume up button, and turning it left can trigger the volume down button. All I needed to do was write a little Arduino code to control everything and get the timing just right. If successful, this should create the illusion of the dials actually working in a similar way as they did originally. So if you like hacking on projects like this, then you're going to like the sponsor of this episode, PCBWay. PCBWay offers inexpensive PCB manufacturing and a whole lot more. Need assembly services? No problem. They can do front side, back side, through-hole components, you name it. They also offer 3D printing, CNC milling, and more. So check out PCBWay for your next project, and I thank them for their support of the Retro Hack Shack. Okay, I've hacked together some power here so that the 12 volts actually goes through this old 45-year-old switch here that controls the power and the volume. So let's hook this up and see if the display will come on when we pull that switch. Got the power connected. Let's see what happens. Oh, I see something happening. Bada bing, bada boom. HDMI. I can turn the TV off. Done. So first switch of integrating the old technology with the new technology is a success.
We can rebuild him.
Okay, so now I want to test out the audio and just make sure that's working. But one thing to keep in mind here is that this is most likely a D-class amplifier. You can go Google and see what that means if you're not familiar with it. But basically, you can tell because if you look at the way these connections are labeled on the speaker, one says right positive and right negative, and then you have a left positive and left negative. And if you connect the negative side to a ground connection, for example, you'll see that they are not connected because they are not ground referenced. All that to say is that if you tried to just twist these wires together and hook them up to a single speaker, you'll most likely blow the amplifier on this board. So word of warning, if you only have one speaker, just use the left side of the speaker because that's typically the mono side. In most cases, you're going to lose the right channel in a stereo scenario. Woohoo! But yeah, just connect one side in this case. If you try to tie these together and connect both, you're going to blow the amplifier. If you have a stereo set, though, you're in luck. You can now take one side to one speaker and one side to the other speaker. Okay, so I've got everything connected and I'm ready to try this out. Let me give you a quick rundown of what's going on here. Here's the rotary encoders over here. Luckily, these rotary encoders are the same size as the original potentiometers that were on here. And so these, the same knobs, I can use the same knobs and they'll fit on this, and you shouldn't notice any difference whatsoever. But here's the rotary encoders that are installed. That's running over here to the microcontroller, which has the software running on it that I built. And when you move one of these knobs or click on one of these buttons, that sends a signal down to the microcontroller, which then sends another signal out of these digital pins here, which are connected to the original control mechanism. Everything still works on here. All the buttons are connected. But what I did was I put some transistors here, which connects this particular switch together, the signal side and the ground side. That sends a signal back to the control board, which then does the appropriate function, whether it's moving volume up and down, switching the channel, opening the menu, whatever. So if this works the way I hope it will, the functionality will be slightly different than it would have been on the original set, because I wasn't able to actually connect to the channel changer, for example, to change the channel. But in all reality, if I use the RF input on this, it's almost always going to be set to channel 3. So I'm not too worried about that. However, the channel function also drives some of the menu functionality to move the menu around and adjust things there. So I still needed to be able to access the channel somehow. So I've got the channel on one button, and I've got the volume on the other button, and I've got the push button functionality here is menu on one and input on the other. Well, so far this is looking good. I can see this is the video of my restoration of an IBM 5151 monitor, the original IBM PC monitor that was sold back in 1981 with the original IBM PC that kicked off the whole PC revolution. So let's go ahead and play it and see what happens. There on the shelf, and that is a 5150. Okay, so the sound is not coming out of the TV speaker, but I think that's because my sound connection I just need to tell my laptop to send sound out of the HDMI port. Okay, let's try it now. Which is the EVA version. There was also a 5153 that was the CGA version. So this was the monochrome. Then they came out with the CGA version, and then they came out with the That sounds so much better actually coming out of the original TV speaker than it does out of these crappy speakers that are in my laptop. So that's a really good sign. Also, the screen looks great. Now let's test the controls and see if I can do things like bring up the menu. So this should be the menu here. Yep, and there's the menu. I can make that go away. I can change the input with this other button. Look at that. It's working. When I twist this rotary controller, it's doing the channel up and channel down to move this around. And then if I move this rotary encoder, it's changing the volume down here. Now it's going in the opposite direction, I think. So this when I move this way, it should be, normally this would be turning the volume up and the other way would be turning it down. But that's no big deal. I can just change or swap the wires on the volume up and volume down over here, and that'll fix that problem. So far, this is looking really, really good. All the controls are working so far. So I guess it's time to move on to the next step.
We can rebuild him.
If you remember, the new display I have is perfectly flat, and the CRT tube is rounded. And you can see the bezel is rounded here. It's flat on the sides, but rounded here, which means there's going to be a little bit of a gap on the bottom and a little bit of a gap on top, which may be distracting from bringing this TV set back to life. So the other problem with this is that what you're seeing here is all one piece. So I was originally hoping that I could pop just the bezel part out because it looks like it's a separate piece, a separate component. And then I could 3D print something to fill in that gap and then spray paint it to match the original kind of brownish gray blackish color of the bezel, but I can't because this is all connected. It's all one piece. So in order to paint it, I would have to mask it off, paint, hopefully it would match. I just don't want to go through all that trouble. So I'm going to try something a little different, which is this EVA foam. So this is foam that a lot of costume designers use and cosplay folks use. to design their costumes. And the reason they use it is because it's cuttable, number one, it's light, number two, it's sandable, number three, and it's paintable, number four. So, and you can glue it as well. You can glue pieces together. So that makes it very, very versatile. And what I thought I would do is go ahead and try to cut a length of this and then scribe this line onto the length. Once I get it to the width of the opening here, I'll scribe that line on and cut it off. And although it's not a perfect match, this isn't exactly pure black either. It's kind of a, I don't know, a dark gray almost. And it's actually not that far off of the original color. It does reflect light a little bit differently. And this has some brownish tones in it, I think, as well as some gray. So I think though, if I use this, I think that'll be good enough to do what I want, to accomplish what I want, which is to fill in that gap there so it's not so noticeable. So that's what I'm going to do next. Okay, well, here's the piece that I cut out, and you can see just how thin and small it is. I mean, it's probably less than 3/4 of an inch here, maybe just over 1/2 inch, and it's quite long. So yeah, that's the piece that I'm going to be fitting in there. And I'm glad I did this with foam because there will be some little imperfections in the curve here. But because it's foam, when I put it in here and get it glued down, it'll give a little bit as I glue it down, and I should be able to make that a nice tight fit. So I ended up just using some regular super glue here to tack down the corners and the middle part so I could test this out and see what it looked like before I actually committed to gluing this all the way in. And once that glue had dried, I put in the display, and look at that. It looks pretty good. In fact, the color matching really doesn't matter that much, I don't think. It looks like it's part of the original set to my eyes. I think that's a win.
We can rebuild him.
Okay, so now I have to figure out a way to keep the screen from falling out if the TV is tilted back. So the screen is in there pretty good, and it's kind of tight against the edges. So it's not moving around a whole lot. So it's not like it's gonna flop around inside the case. But like I said, tilt the TV up the right angle, this will just come out and flop out backwards. So I guess I'm in a foam mood because what I decided to do was take a little bit more spare foam that I have laying around, and I cut it up into these kind of T-shaped pieces. So I can use this to actually screw into the mounts. This is where the ears from the CRT that was held into place were right here where these screws are, these screw holes. And luckily, I saved the spare parts from the TV when I took it apart because I thought I might need these screws for something. Just pop them through this foam, screw them in here, and that's really all I should need to hold this down. I just need a little bit of gentle pressure. This is a very light screen. It's not heavy at all. So a little bit of gentle pressure will hold this screen in place and keep it from flopping out should somebody knock the television or press against it or something like that. And the foam is pretty tight, but as you can see, it's not putting a lot of pressure on the display itself, which, too much pressure could cause some distortion in the picture on the display if there was too much pressure on it. So I think now it's time for a poke test. Yeah, if I really wanted to, I could poke on that display and get it to move a little bit, but it's almost very springy. It's not coming out. And if I turn it this way, yeah, a little springy, but not really going anywhere.
We can rebuild him.
So the next thing I wanted to tackle is how to light up the channel indicators for VHF and UHF on this set. These would have lit up as soon as you turned the power on, and whenever you changed the channel here, they would illuminate what channel you were actually connected to, so you knew where you were at in the TV frequencies. The original TV had incandescent bulbs that were lit up, most likely with AC voltage. And of course, there's nothing to connect these two anymore, nor would I want to. I think this situation can be easily resolved with some LEDs if I can figure out how to hold them in place. So I took the tuners out, and I just love the way these numbers look on the dials. I mean, how cool is that? The orange plastic with the black foreground there to make sure that only the number lights up. I don't know. I just found it really, really cool. So here's an example of what those incandescent bulbs look like that used to light up the dials. They had a reflector in the case, which, you know, made them shine forward through the numbers. And then here's an example of the holder in one of these. And I think I can repurpose this and put an LED inside and make that shine through the numbers really well. Okay, so I've got my LEDs installed and I hooked up the tuner assembly just with a single screw for now, and brought out the wires, and we can just use a simple coin cell battery to test this. So make sure you don't get the polarity reversed. Coin cells, the big flat side on the top here, it's usually marked with a plus. I'll put my positive wire there and I'll put my negative wire on the back. There we go. Look at that. Very bright, very readable. I was a little worried they would be too dim. But yeah, this is going to be just fine. Look at that.
We can rebuild him.
Okay, I'm getting really close now to finishing up this project, and I'm getting pretty excited, so I hope I don't go too fast and ruin things. But here's another look at the board with all of the inputs on the back there. And I was looking around for a place to put this, and it looks like, conveniently, there are some mounting holes. There's one here and there's one over here on this side. If I look inside the back of the case here, I can see that there's actually a little plastic support here. I could actually use this and screw through that hole to mount this right on the back here. And then I'll just have to find some way to mount this other one on the other side over here, because I think I'm going to need that. But anyway, it's a super convenient place for them to put a little piece of plastic. And this is going to fit in there super, super well if I drill the holes in the right locations. In order to support the other side of the input board, I just pulled out an old project case that I had 3D printed for something. I always like to keep these around for just this reason, and I was able to cut a corner of it off, which will act as a support. And I'll just epoxy this in to permanently attach it to the back of the case. And with that in place, we can turn it around and see how badly I butchered this thing. Well, actually, it doesn't look too bad, really. I mean, some of the hole cutouts are a little too big, but this will work just fine for plugging in all the inputs to the back of the TV.
We can rebuild him.
Okay, well, it's time to start reassembly, and I've already run into my first problem, although I did anticipate this, and that is that this bracket here, which holds so nicely all of the pots in the new rotary encoders that I installed, used to screw into the chassis that was holding the CRT in place and the PCBs down here. And it also had that PCB here that was installed here. And anyway, there were screws and everything that held this into place, but now those are gone. And if you were to push on the knobs on the front, it could cause this to come off. There's nothing holding it in place anymore. I think I'm going to try to tack it on with a little bit of super glue first. Okay, well, that didn't work. It only held for a few seconds and then it snapped off. So I'm going to try some E6000 glue instead. This stuff works really good to bond metal to plastic, and it is removable, but also very strong once it dries for 24 hours. So I'm going to try this and kind of stepping it up in terms of, strength and, unfortunately, the ability to take the thing apart again. So once I get to epoxy, it's going to be really hard to take apart. So I hope this E6000 works.
6 hours later.
Okay, well, the glue has been drying here for about 6 hours, and it does feel pretty firm already. I can lift up the whole front screen here of the TV without any problems, and it looks like it's equally firm on the back. So even though it's early, I do want to test this out. So I'm just going to put the power button on and hold it from the back while I push this in, just to be sure, because that's where the bulk of the pressure comes from. Okay, so that's all the way in now, and the test will be, can I turn the TV on and off a few times without seeing any noticeable movement in the bracket? So here we go. That's the easy part. Oh yeah. Way better. I use it in a lot of my projects, and it's always when I'm in a situation like this where I need something that bonds really well, but I can always take a knife and cut around that glue and take it off later. It does get a little bit hard. It's not going to be easy to get off, but you can take it off and salvage your components without breaking them. And just after I recorded that segment about that glue and how it's good that it can come off, I realized that these knobs do not go on from the front after you put the bracket on. They have to go in first.
Emotional damage!
Unlike these other knobs back here, which are pushed on from the front after the bracket's in place. So that means I need to take this off so that I can put these on these posts first and then put it in and then put the other dials on. So yeah, I didn't realize that when I was making the comments about having to take this off, but that's what I'm going to have to do. I'll take it off, put these in, let it sit overnight, come back, and hopefully test this thing out. So once the glue was sufficiently dry, I went ahead and started putting all the connections together and then gave everything a really good clean with some Windex and a little bit of elbow grease. And as you can see, the dials are now sparkling. I mean, they're not perfect, but they are definitely mirrored again so I can see my reflection. And I was really surprised how much grime was just on the surface of these little color tuning knobs. They really came out looking brand new when I was done.
We can rebuild him.
Okay, so I thought I'd try this out with a few different inputs, starting with this one. But first, let's just go ahead and turn it on and make sure it's working. So pull the power button out, and you can see the channels, hopefully, how nice they look actually with the LED in there. I did not think they were going to look that good, but they look really good. And you can also see as this comes up how some of the menu items are cropped, and I'm okay with that. Like I said, we're losing about a ½ an inch off either side just due to the size differences, and that's as close as I could get it. But I think as you'll see as we play through, especially with the older sources like Pitfall, it was assumed back in the day that there was this bezel was going to overlap the tube somewhat to cover up the edges of the CRT where the signal was coming in, because they can be quite bright sometimes. It was assumed that there was going to be some overlap. So when they, made games and things like that, they designed them with some, buffer around. And so I think what you'll see is that it actually works really, really well, even though we're missing a little bit of space on every dimension here. Okay, so let me make sure that the input is set to, let's make sure the controls are working first. And we can do that by making sure that the input is set to analog TV. And it is ATV. And you can see the controls are working. I can go up and select a different media source if I want. So I have full access to all the controls, all the things that I might need to change if I do need to change anything, without having to either make that back panel of buttons accessible or having to resort to using the remote. Now, I do have the infrared hanging out the back, so I can use the remote if I want to. It actually reflects off of things in the room. So if I wanted to, here, let's just bring up the menu again. As you can see, even though the infrared is in the back here, it still picks up the infrared signal. As long as I'm not pressing right at the TV, if I hold it off to the side here, that works as well. Am I not plugged in? It's always a possibility. Oh, there we go. Okay, so we've got a scratchy power button here. Let's see if it'll, there we go. Okay, and even the feedback loop, there was always a little sound. I don't know if you can hear that, but there was, when I played these games on a TV just like this, I swear, back in the day, there was always a bit of a ground loop or something, some feedback coming through the speaker, and that's still true today. So, yeah, let's just see if this will work here. Yeah. Oh, there we go. There we go. This joystick, this is one of the original joysticks, and it is a little bit scratchy. I've cleaned it up a little bit, but it's still a little scratchy. But as you can see, the picture fits in fine. It's a little bit off on this side, but the picture does seem to fit into the on the display just fine. Pitfall was always one of my favorite games. Ouch. And you can hear how loud that speaker is, hopefully. I don't know how many countless hours I've spent on this thing. Oh, here's the tough part. Let's see if I can do this the first try after after not playing this for a while. Let's see. Here we go. Ready? Got to time it just right. Wait for him to close. Woohoo! Look at that. So this looks really good. The viewing angle on this isn't the greatest, I will say. So, if I stand off to the side, I can still see it, but to get the colors sharp, it's actually the vertical viewing angle which is off. I have to to get the colors really sharp, I kind of have to look at it straight on. So something to keep in mind with these probably cheap panels that you're getting online is the viewing angle might be off. And I think appropriately, I'm testing this with a heavy sixer. For those aficionados out there, you'll know what that is. Yeah, this is the original Atari, later named 2600, but when it first came out, it was called the Video Computer System. So very period appropriate for this particular TV. And you can see there the way the tuner works is it actually cuts off the signal when it doesn't see anything anymore, so you don't get that static, which is a really nice bonus, actually, of how this particular chip works on this system. Okay, now I want to test the composite input. So I've pulled out a composite computer to test with. This is the Apple IIc, not period like the Atari was before necessarily, but Apple II, certainly the original Apple II, would have been period for this particular TV set. It's just that this is smaller and easier to use and has composite output. If you're wondering why there's no cover on this, then you should probably watch my video where I was showing how to do some mods and things and ended up destroying and burning the case, the top cover of this, and starting a fire in my study. So yeah, if you want to watch me start a fire and learn a little bit about the Apple II and the process, you can click that link above there. But anyway, I know this machine works and it works well. The drive works well. So I'm using this to see if we can get a composite signal. So let's go ahead and turn it on. And there we go. Apple IIc. Of course, it's not going to do anything because I have the disk out. But there you go. Apple IIc is up and running and looking great. And it fits nicely in the display that we have here. So let's go ahead, and this should be Oregon Trail. I had to make a new disk because I lost my old one. And funnily enough, in the old days, you didn't put your floppy disks on top of a TV or a monitor because the magnets inside could erase the data or corrupt the data on the disk. And so as I'm sitting here, getting this ready, I was keeping my disks far away from the monitor and totally taken by the illusion of this set, thinking that it was a TV set, a real TV set, when, I guess it is, but it's got all new electronics in, so there's no powerful magnets. It wouldn't happen anymore, but I got totally taken by the illusion of the TV sitting here. So even as I've been working on this for the past couple of weeks, I still get taken in by the illusion, which to me is just awesome. So here we go. Oregon Trail, copyright 1985. Again, a little bit late, but it does show the color coming in on the composite. And here we go, going back to 1848. It looks great. Again, the only thing missing here is really the scan lines to let you know that this isn't a real tube TV, in my opinion anyway. Okay, guys, now I want to test out HDMI, and not just HDMI. I'm going to be testing out the HDMI, RGB to HDMI adapter that I sell and use all the time, by the way, but I sell this on my website, retrohackshack.com. It's a great device to take either analog or digital signals out of your old computers and convert those to, high quality HDMI, lots of custom configurations you can do with this thing. And of course, the project is really being maintained by the wonderful Ian B. Shout out to Ian, who is kind of maintaining this project and who I've been working with to bring these things to the marketplace. So yeah, you can find these on my website. But it's a great way to test HDMI and relive some of my childhood at the same time because, as I mentioned, this set is very similar to the one that I had growing up. And this first rev of the TRS-80 color computer from Radio Shack is the first personal computer that I ever laid hands on and ever used. So this setup right here with the color computer and this monitor from 1976 is almost identical to what I had growing up, and it is extremely nostalgic for me to see both of these things together at the same time. So anyway, we're going to be putting HDMI out through the RGB to HDMI board, like I mentioned. It'll take the signal from the color computer, convert it to HDMI, and send it, hopefully, to the screen. And let's see how it looks. Let's go ahead and power it on, see what happens. Okay, now this is normal. It's the Raspberry Pi boot up screen. Okay, now I've got a special cartridge here. It's the SDC cartridge that a lot of people use. I use it all the time with color computer. Normally, when you boot up the color computer, you would see a screen like this, but with the little flashing cursor. But because I have this in here, we can now explore all of the games and stuff that are on this particular image in this thing. And I want to pull up a game that definitely shows the color. I'm going to pull up Zaxxon. Now, Zaxxon is actually the game that I use when I'm testing. I test all of these RGB to HDMI boards. I test it with Zaxxon because I know what it looks like. I know what the colors are supposed to look like. And it just is a great test for me to make sure everything's working before I ship these things out. And by the way, thank you if you've bought one of these. So many of you have bought, I've shipped these things around the world at this point. So just thanks everybody if you've bought one from me. I hope they're working out for you. I've got a lot of feedback. A lot of people tell me how much they like them and use them. So anyway, just a quick thank you to anybody out there that's bought one of these boards from me. Okay, so let's go ahead and fire up Zaxxon, see what it looks like. Here we go, the official Zaxxon. And you can see this is actually by Sega in 1983. And you can see here was programmed by Stephen Bork. So let's go ahead and hit one player and see if this thing works. Oh, yep, there we go. Looking good. Now, this is a little bit easier, in my opinion, than the, as I die. This is a little bit easier than the arcade version, I think. And also because I played it, so much as a kid that the muscle memory is coming back for me at this point. Yeah, this is a good game. The colors look great. The set looks great. So wow, this is just really, really nostalgic for me right now, guys. This is incredible. I can't even focus. So anyway, yeah, this is looking great. Colors look great. Yeah, just brings back so many memories. Okay, one last thing I want to test. There is also a USB port on the back of this, but it's detected, it looks like, that I have some movies on this USB thumb drive. Oops, there we go. And sure enough, I do. So we can kind of scroll down here and see, here's Computer Chronicles. These are all just MP4 files. I haven't tested every file format here. But you can see it pulls up a preview there of the show. And it's got all the information up there for, controls and things like that. And if I hit display, that should go away. There we go.
Video games have come on hard times these days with closeout sales, discount prices just about everywhere. But what about computer games? Well, as computers have gotten better, computer games have gotten better too, with vastly improved graphics, much more sophisticated text handling, and much greater speed. We'll take a look at some of the newest and hottest computer games next on the Computer Chronicles.
So let's see, I should be able to pause this. Yep, you can pause, you can fast forward, all that stuff, and play whatever video you want. And again, it just looks perfect on this set, even though Computer Chronicles started in the 80s, I think, early 80s, and this set's from the 70s. But, if I was watching this, I would still be watching it on this set because TVs were expensive. I think we had our TV around for a good 10 or 15 years. So we definitely would have been watching Computer Chronicles on this set, on a set just like this one. Okay, well, here we are back in the 70s set. This is exactly where this particular TV set belongs, and it just fits in perfectly. It looks perfectly, and what I love is even I got fooled by it when I first started using it. The way the channel numbers light up on the dial and the way everything works, the ability to control it from the front panel, and it just looks great. I really feel like this is kind of the bionic TV set now, if you will, because really, I mean, it has a lot of features it never had before. So for example, it has a remote now for one. It has every input imaginable on the back so that I can play any source while I'm sitting here talking about a game system or an upcoming episode. And I think it's going to make a wonderful addition to the set. And also, I just look forward to plugging things into this as I need to for just using it as a regular monitor. I think it'll be great. Now, for those CRT purists out there that say, oh, I would never do that, you should always use original CRTs. Well, in this case, I'm really glad that I saved this thing, because you've got to remember the flyback transformer on this set originally was shot, and the only way to get another flyback is to find another model just like this one, or maybe, you know, a model that had the same flyback, which there'll probably only be a few TVs that have that flyback. And if the flyback is working, it probably means the rest of the set is working or easily repairable. So yeah, I'm not going to rip apart a perfectly good TV to get the flyback out to fix this one. On top of that, the CRT I had before, there's no telling whether it was any good or not. It was obviously a high hour set. So I feel pretty good about the fact that I was able to remove those components and then actually bring this back to life without sacrificing the chassis itself. And so, yeah, I feel really good about my decision. And there are other CRTs out there. There's nothing like a good CRT for sure. But in this case, I'm really glad I saved this the way I did. Now, the other thing to keep in mind too, there are some challenges if you're looking to do this yourself. First and foremost is the screen size. You're really going to have to pay really close attention to the screen size and try to match that up as much as you can, while still keeping it a little bit bigger than the opening that you have. I can link this one down below if you want to see an example, but don't take that meaning that this will fit any TV. It obviously won't. So make sure you measure the opening that you have and try to find a panel that matches that as much as possible. That's number one. Number two, the panels that you will find like this are actually going to have a challenge in that they're meant to go in monitors. They're meant to go in very thin casing and not in a TV set like this where you want to mount the controls all the way in the back. They're meant to go in monitors that mount the control very close to the screen. And so I had to do quite a bit of extension to the wires that are in there. And so that creates a bit of a challenge. And in terms of opening and closing this, I want to make sure that there's enough wires so that I can get in there and do that and still close the setup. And I'm even waiting for an extension to come in now so that I can actually improve on this design and extend the wires that I need all the way to the back. So something else to keep in mind for sure. And the last thing I would say is take your time. Make sure you, like for the glues, for example, make sure you're using the right glue. I was really, if I had used resin on this back plate that's holding the controls in place instead of that flexible E6000 glue, I would have been out of luck when it came time when I forgot that these dials had to go in first. I would have been in really bad shape and perhaps had to break the plastic off to get it off. So use a glue that'll work and just go slow, take your time, progress through, like this is the least harmful way to do it. And then maybe this other thing could be a little bit harder, and then, you know, kind of work your way through the progression like that as you're working on this, and take your time so that it comes out great and you don't end up like I almost did with an unrecoverable error. So I really hope you liked that episode. Be sure to give this a like and subscribe if you haven't already, or become a patron. You'll see my patrons in the credits and their names will be coming down. And I thank everybody for their support of the show. So with that, until next time, we'll see you later. Patrons receive ad-free and early access to content after the episode commentary, and of course, your name in the credits. If you liked that episode, here's a few more you might enjoy, and I thank you for your support.
End of line.